Right, so this is the third session. I've seen many of you in the previous sessions, and you may miss some because obviously it's hard to find dates that work for everybody. But you may have seen the recordings as well. And you may want to go back to them and just skip through them or look at the presentations. I will honestly say that there's nothing really simple about this, even though I tried to make it simple. It isn't that simple. It's a different way of thinking, a different way of working, and I think we will need the remainder of the project to really get our heads around this. And at the end of this third session, I'll propose, or we can discuss some follow-ups, things that need to happen still. So I don't expect this to be a sort of thing where you go 3 sessions and you're done. I wish. Myself, I'm not, to be honest. I've used this trilogy as a way of forcing myself to look into these matters, and I'm still not there yet. So if you are, then probably you should do the next trilogy. Okay, so let's get into it. We're recording, as I said. This should be session 3, not 2. Let's fix that straight away. Okay, so maybe a quick reminder what we did in the previous sessions. In the very first session, we looked at really at what is semantic data. How do we use the federated semantic data model? How would you go about constructing data for your own lab? And how would you work with other labs? And we actually worked through an example there. And even though the example was a little bit contrived, it wasn't perfect, it wasn't exactly aligned with the semantic model, for the purposes of understanding, I think it did its job. In the last session, we looked at how would you actually implement a semantic endpoint. And I took you through that, found some shortcuts, and I was actually really happy that Rudy managed to follow the instructions during the presentation and got a semantic endpoint up and running while we were listening. So that was a bit of a relief to me, because you never know with this stuff. You make it look easy and then it turns out it doesn't work when you come home. It looked like it did. So that was useful. Now we're at a point where we kind of knew how to make some data. You might even have had some discussions with our labs about what you could exchange. Then we managed to get it live, up and running on a semantic endpoint. And now the session is about, okay, how do we query the data? We have the data, it's up and running, how do we query it? And so we'll look at queries themselves and how they work. We'll look at how to write your own semantic queries, the easy way. And I said cheat sheets, but actually I've reduced it to 1 cheat sheet. So it won't be hard. Actually, this is the easy part. And then we're going to use queries to do some to query semantic data, both within a lab and between labs. So that's what we're doing today. That's the sort of the practical thing here. What I'll do, following Rudy's suggestion last time, I need to somehow package all of the examples so we can share them out so you can actually replicate it without having to go to the slides and start copying data. So we'll try and make that easy. But I'm pretty sure that even though I say it's easy, you'll find it'll take you a bit of time to get it working, but the examples are there. So let's get into it. Semantic queries. I see that the subtitles are back. Stop them again. Thank you. Semantic query. So the first question is, what is a query? And as you can see, I've just realized that I borrowed this from Adobe stock. So I probably shouldn't publish this, but I'm going to anyway. So what is a query? Actually, I had to think of, I don't know whether you have done, I hope you have, sat around a campfire with a bunch of friends, maybe in your 20s, no responsibilities, no family, no mortgage, no job, no nothing, or maybe a job, but not one that you could not leave, by a lake, and just think about the meaning of life. Look at the stars and go like, oh, wow, how is this, this, and this? That's a query, it's a query about, in this case, the universe or life or whatever, love, all the things you can imagine. And that's a query, it's nothing else. In fact, if you look at the other words for query, it's all of these things here. It's a question, it's an inquiry, it's a question mark as well. And of course, you need some answers with that. But for our purposes, a query is formulating a question about data in a logistics and transport network. And fundamentally, I think that is really what our living labs and what our project is about, the FEDeRATED project. And this may seem a bit convoluted, but one of the issues we have when we are running logistics and transport services is understanding data that's upstream or downstream, or that is in some third-party resource that we don't have access to. It's simple questions like, to come back to the example I discussed with Sjoerd about the terrible queues at Schiphol Airport. And by the way, it's not the only airport. That's the bad news. It's just one of them. But the bad queues at the airports, the question is, well, will I make my flight? How long is this queue? How much time will it take me to get through the queue? These are the sort of questions that we have when we travel. And transport logistics is the same thing. When is my freight arriving? What's the value of this particular shipment? Are there dangers when you're a fire brigade person? Is there dangerous goods in this particular package that's on fire? You know, questions like that are the sort of questions that we ask in operations, that our colleagues ask in operations as they are navigating this thing. And so the FEDeRATED approach is really trying to make sure that in this ever increasing complex network, we can get answer to these questions quickly. We know we can get answers to them because it's working today, but getting them quickly is really what the challenge is. So querying is fairly fundamental in what we're trying to do here. So you can query a living lab, and we'll look a little bit later at doing that. I've got some examples there. You can query any living lab. And now, in reality, probably most labs have different approaches to querying. Somebody may build a beautiful user interface for you. You just go to a web page and you type in whatever. When is the next available? I got 10 tons of cargo. Who can carry this and when and what would the cost be? These are good queries that you might do through a platform like that with a nice user interface. Or you may not be at that level. You may have a traditional relational database and you'll use something called SQL to query the database and get answers like that. You may not have anything and pick up the phone and call your colleague and say, hey, when is lunch? Because that may not be in your database. But the interesting thing about the FEDeRATED network of platforms is that we can actually query the entire network, which is why we're trying to have this common approach to a semantic data model and a semantic query approach using these semantic endpoints. And so what we're trying to demonstrate, I think, to our colleagues from the EU, INEA in particular, and the Digital Transport and Logistics Forum, is that this can work. You can actually network all of these different platforms. We call them living labs, but they're platforms. Connect them all and somehow query them as if it's one big database. That's what we're trying to do. What we'll see at the very end of this presentation or this session is that this is not as obvious as it sounds, that the sort of queries that we might do are not obvious at all. And one of the things you will have discovered as you're going through the homework that I proposed to you, and that I think Roland has also repeatedly asked, is how are you going to interact with another living lab? That question is a difficult question because the answer really isn't obvious, but we'll come back to that. Let's stick with the purpose of this session first. So smart computers can use natural language processes like Alexa. I haven't got an Alexa. I will admit to that. I don't have anything for that matter. I don't like computers in my house too much that think for me or that mess things up. But anyway, some of you will have Alexa, and you can just talk to her and say, hey, could you play some jazz, or could you turn the lights on? And you don't have to say, Alexa, lights on. You just say, could you turn the lights on? Just use natural language. This is increasingly, this technology is increasingly available. Any new system that we build could easily integrate such an approach. And in fact, we run these hackathons, and in every hackathon, there's at least one team that introduces natural language processing in order to interact with an app, with a chat bot or whatever. So that's fine. Going forward, not an issue. But today, unfortunately and sadly, we have to use relatively confusing language. In our case, it's called Sparkle, pronounced Sparkle, like I just did. And you'll see that it's confusing. It confuses me. I think the only people that are not confused by it are people that just do this 8 hours a day. And to them, it's like, yeah, whatever. In the same way that Chinese confuses me, but if I were to learn Chinese, then probably it wouldn't confuse me, hopefully. And it's the same here. You have to learn it, but we're not going to do that. I promise you, you won't have to do that. And so IT people like that, but we normal people probably don't. So just bear with me. I can't do it in any different way than to show you the horrible insides of computers by introducing Sparkle. But we need to go back to school. You'll see why I use the term school and talk about triples. So triples is a fairly fundamental aspect of language. And so I've got some examples here that there is a company that has a name, and the name is IATA. There's another company that has a name that is Vidya Oi. I don't know whether it's Vidya Oi or Vidya Phi or just Vidya. Hopefully my Vidya colleagues will clarify that one for me, but I've seen it used in different ways. But anyway, there's a company with that name. And there's also a company that has a location in Geneva that happens to be IATA. So the way that people in the semantic query business look at this is they say that you have something, this, that has a relationship with something else, that, okay? And so this company has a relationship, has name with that, IATA. So that's fine. And in fact, the professionals use different words for that. They talk about subject, predicate, and object. And honestly, this confuses me all the time. Predicate is not a word that I use all the time. I studied mathematics in the past, and yes, we used predicates, and they probably mean something very similar, but it's not to me, it's not a very meaningful word. If I were to do this 8 hours a day, it would be. And then subject and object are killers for me. I'll share with you that although at school I did well in physics and maths and biology and chemistry and all that stuff, the one topic where I always failed was language. We called it, in our case, it was Dutch. It could have been Swedish for you, or French, or Spanish, or Italian, or whatever. I always failed, and one of the main reasons I failed is that I couldn't tell the difference between a subject and an object. And at the time, I just thought I was stupid, and it never occurred to me that there was a reason why I didn't get it. And the reason I didn't get it is that a subject can be an object too, right? If I look at this example here, there's a company that has a name that is IATA. But I could also turn it around and say, IATA is a company. And so there's nothing intrinsic about subjects and objects. So I find them confusing. So let's just forget that. So I'm going to be using the sort of has relationship and all that from now on. So is that all? Actually, yes, it is. This is all you need to really understand about semantics when you want to do queries, is that concept. You have something, this, that has a relationship with something else that is that. And so just, putting that very obviously here, company has name IATA, this has relationship to that. Put some color codes there. And now we can ask questions, right? We could say, well, list all companies that have a name. Now, if this is the only data we have, there's only 2 entries, the first 2 that have a has name relationship. And that is then IATA and Vidya Oi. I realize it's a mistake in the following question. It says, where is IATA based? Well, you have no idea because the data doesn't show that. I would have the link IATA with that company has location, but let's don't worry about that. So a better question will be, where is a company based, right? Let me just fix that because this is probably, I'll forget to do that otherwise. A company based. I'm learning. So where is a company based? Well, there's only one company that has a location, and that's Geneva, right? So we can see that. So this is a kind of strange way of asking questions, but it all comes back to these triples. And abstract as that is, when you think of data, or no, when you think of language as actually being lots of this and that, you know, like the reason I failed at school was I couldn't tell the difference because it all fits together. So you could have a whole story where you say, well, there's this company in Geneva that has a name IATA that works for the relationship airlines, in particular airlines that carry cargo, and that carry would be the relationship. And so you can construct these phrases, these complex phrases, and they all have these triples built in. You can always pick out three things. There's the company has a name IATA, IATA has a location in Geneva, IATA provides a service to airlines, airlines carry cargo. You can always find these triples in there. And so you can really represent the entire knowledge of the world with triples, which is exactly what an ontology is. And so you just have to kind of remember that you need to find the triples in the language. And when you do that, you can start asking questions. Now, as I said, this is something that happens in the real world. It's a network of facts. Facts are data. And so in other words, the federated network of platforms is really just a network of data that represents the data. That's in the federated ontology. So it's a new way of looking at language. And certainly if you want to go anywhere with semantic data, with queries, you need to come back to these triples. So in the EU, a network of data is also known as a data space. So you'll have heard that term. And now perhaps it makes sense because you can think of everything around you, the work that you do, but also the work that you don't do, you know, the stuff at home, your hobbies, your traveling, your whatever. It's all, you know, data that's linked to data, and all our conversations are that. Now, a nice term in I think it comes from mathematics is to refer something as a space. It just means that you talk about something that fits together and they call it a space. So in Europe, they call it data space. But I have noticed that in other parts of the world, they don't use that term in the same way. So it's a European thing, but that's fine. We're Europeans. We're in a new European project. So, okay, so good. I think we've got the triple understanding. So going back to, going back to screen. You may remember this from session number 2, where I created some artificial data for a company that doesn't exist. This company is called Italia Logistica. I don't pronounce that correctly, but I think you can probably work out what it means. So there's a non-existent company that has a actual time of arrival servers for their trucks, probably. And so we created this little service here, and it refers to the name of the service provider, which is Italia Logistica. We have the actual time of arrival event with the time that goes with it, time and date, and then is also reference to a booking number. Very, very simple example. This is the sort of data that we will see traveling around the federated network of platforms. This is exactly the sort of data that we'll see. And forget the bit before, you know, it says context, FD. It's actually just a shortcut. We call it the prefix. FD is a prefix. And so below, when it says FD, it just means HTTPS, ontology, TNO, NL logistics are federated, but not to waste too much screen space, and more importantly, not to waste too much data that travels around the networks. We use these prefixes to shorten it. Personally, I do it because I find it a lot more readable, because otherwise you're just seeing URLs all the time, and that's just confusing. But it's a very simple example. It's 3 data points, and that relate to the service provided by this company, this ATA service. Okay, so this is in the previous one we used that. Now we're going to use it again through a query. So remember what I said, that everything is these triples. This has a relationship with that, and I've used the color codes. The this in this particular format or example, the this is that service, the ATA service provided by Italia Logistica, Veloce Logistica. The pink, I think it is, I'm not sure because I'm colorblind, but I think that's pink, is the relationship. So now it makes sense, right? Because this is this service. Let's go to the last one. That's easier to understand. This service has a booking number, which is this 464646. Has a booking number is actually a relationship. I have a service that has a booking number, which is 464646, which is the that, okay? And it has an event with data. The first one is a bit confusing because there's a company called Italia Veloce Logistica that has a service, of which the service provider is Italia Veloce Logistica. Duh, we know that. Except that computers are a bit stupid, and so you actually need to spell these things out. But it doesn't change the fact that we have this triple relationship. I can write this differently and turn it into phrases, right? Like I just did. So the ATA service of Italia Veloce Logistica, I should have used a shorter name because it didn't fit on the screen otherwise, is a service provided by. It has an ATA event at. It has a booking number 464646, okay? So now we discover the triples. We can ask questions, complex questions. We can ask a question that we would normally ask. We would call them up and we would say to them, what is the actual arrival time of Italia Veloce Logistica transport with booking number 464646? That's a totally reasonable question. And we can ask it because we have the triples here. Now, I can't remember if actually, no, I don't go through it. But so if you would take the first part, what is the actual arrival time? Well, all we know in this question here is what is the actual time, arrival time of Italia Veloce Logistica? Well, I'm looking for a Italia Logistica transport. So I'm going to ask that, and actually it turns out that all of these things have that in the very beginning, right? So there is a service. I can now ask the question, is there a booking number 464646? Yes, there is. In that case, I now know that this particular file, or this particular data set, if you want, has a booking number, has the Italia Veloce Logistica company, and now I can find out what the ATA event is in it. The answer is 4 April 12. So you can see this is like a little bit complicated. In fact, you could probably create this, make a little game out of this for the New York Times. When you get bored with Wordle, you can do this. You can say, okay, I'll give you a bunch of triples. I'll ask you a question. Can you reason your way through these triples to find the answer to the question? Now, fortunately, I think most of you will not have to do this. I think this is for your IT colleagues. You tell them the sort of questions that you want to ask, and they need to figure out how they have to work through these triples, okay? We're actually going to do that. So you'll see how you do it. Unfortunately, computers help us to do that. And this is where Sparkle comes in, okay? So just let's sort of take a little break here. I know that this stuff is not easy on any day, but in particular, Monday, 10 o'clock. I don't know whose idea that was, probably mine. But let's just step back a little bit and go right back to the beginning. Remember, this is all about being able to get data about the services that we provide within a larger context. Right now, we're doing this on a European context, which is already enormous, but probably many of you are involved with things that are much bigger than Europe as well. And so, in fact, I can guarantee that you are, even if your actual service may not necessarily be sold outside Europe, the goods that you transport will certainly come from other places around the world. So it's all about asking questions. And we can ask questions. We have to formalize that a little bit because we don't really all use natural language processing yet. We use this confusing way of breaking up perfectly good language into triples and then use the triples to ask questions in a very, very convoluted way. Is what it is. One of the nice things is, and let me just go back one slide. There's something really quite intelligent in a way about formulating this data in triples, right? Because what's the alternative? The alternative is, for example, that we don't provide the first part, right? The yellow one, and say no. You know, the Italia Velociologist has sent me some data. I know it comes from them, and so I just need the rest. That's enough. But then what if, you know, let's say it was in an email that provided that information without the yellow part. The first person that receives this knows where they got it from, so fine. They know that this refers to this particular company. But the next person, they don't know where this came from. Was this actually, who originated this? Who's providing the service? Okay, it says Italia Velocilogistica, but did it come from a third party? Can I even trust this, right? And so you can't really leave out the yellow part. You can't leave out the pink part either, because you kind of need to know, you know, what that 4646 means. If I would have just had a like a very very common data field is ID, what if I just had ID colon 464646? What does that mean? Is that a phone number in a small country? Is that a mistaken arable number? I don't know what it is. And so by including the triples, you really create that language, that network of data that means something when it's together. And in the traditional IT world, we never did that. We would only ever have duo, I guess. We'd have a name and a value. You would have to figure out how these things relate. So I think it's a way forward. I think that a lot of companies will be taking this approach, but we're a little bit at the leading edge here, right? So you would not certainly not have learned this at school, and your company may not do this yet, but it's certainly, I think, going to stay. Now, that matters. I'm sorry, I'm just using a lot of words, so better remember, I'm giving you this break time here. It matters. I think that the work we're doing at the FEDeRATED project, we will not redo this, right? Whatever we come up with, the DT lab will live with it for the next 10, 20 years at least. So we kind of have to look forward a little bit. So it makes sense to focus it. And I don't agree, by the way, with Steve Jobs that this is a waste of time. But anyway, it's for him to say, right? Okay, let's get into the query business. First, I'm going to explain Sparkle queries in one slide. If there are any Sparkle experts on the call, they'll be surprised that you can even do this, but we're doing it, right? Because we have some, an empty slide. So just as a reminder, triples, 3 columns, a this, relationship, and a that. First one. It's really easy. So let's not worry about getting confused. Let's just first see what this does. Let's say that you have a set of triples. Remember that example I gave you with 3. But actually, typically, you'll have hundreds, if not thousands of triples. Because remember, you may have 100 transports per 1,000. Or if you look at a whole year, you may have 10,000 bookings that you have worked through or that you are planning. So a set of triples can be huge. It's just basically a great big list of triples, which is kind of nice because it's what we call flat. It's just no structure. And so you have a huge number of triples. And so a very easy query we can do is, well, give them all. I want to see them all. And so if you go right back to the bottom, so what you could say, well, select all the triples in this enormous data set where this is this, relationship is relationship, and that is that. Now, for the mathematicians among you, this is always true. We don't care what this is, even if it doesn't exist. This is true. So is relationship equals relation, and that is that. In other words, just give me all the triples. Now, I kind of use that a lot because half the time my stuff doesn't work. So I just do this to see that I did actually get data and I can see it. So it's actually, for me, a very useful query. And by the way, you remember earlier on, I said that the experts in this call it object, predicate, subject. No, other way around. Subject, predicate, object. See, I would have failed this test again at school. Subject, object. And so what they often do is when they write question mark, they do question mark O for object, question mark P for predicate, and question mark S for subject. And so a lot of examples, if you Google this, you'll almost always see question mark O, question mark P, question mark S. But for us, we use this relation that because it's much easier. So that would actually do that. Now, to maybe explain why it says what it says, select simply means that comes from the world of SQL, relational databases, where they use the word select. It just means take the data, select the data. Distinct, forget about distinct, it's not important, it's just there. There's a story behind it, and I'm sure you can find out if you were to Google that. The question mark actually just means it's a variable, right? It means you can take any value. Again, I find it confusing. In my world, you don't put question marks before words. I know the Spanish do, but the non-Spanish do not. So it's kind of weird that, but fine, these are weird people that have designed this. In fact, I used to work with a guy that was involved in that, but he was weird. I can confirm that. So question mark this, question mark relationship, relation, question mark that just means select these variables where these variables meet this condition. And the condition is that this is this relation. Okay, fine. I won't repeat that. There's also a full stop at the end, very important. If you're actually going to try this out, don't forget the full stop because it won't work. So that's a really easy query. Now we're going to have a really meaningful query. And that is where we want to actually find something in the data set that actually is what we're looking for. For example, let's say that you have a set of triples that relate to the goods that your company can carry. Simple example, which could be bulk, it could be dangerous goods, it could be live animals, it could be perishables, whatever. You have like thousands of triples that refer to all of these different services that you have. And so you're only interested, for example, in live animal transport. And so what you could do is now, instead of saying this equals this, you can replace it by a particular value, for example, horse, And so you could actually then essentially filter out everything that doesn't have horse in it in the first part in the triple. And so then you get everything where the subject is horse. Let's take a better example. Let's say that in our triples, we have something like our transport service can carry, would be the relationship, something. And that something could be anything: horses, dangerous goods, cows, ants, flies, butterflies, whatever. So we do that, by the way, in air transport. These are the weird little animals that we transport. But anyway, this company can carry horse, right? So can carry will be the same for all the different cargo, and the company wouldn't change either. So now, instead of doing value under this, we would do the that, and we say horse. And now we will only get the services related to horse. And maybe you have lots of different services. Maybe you say, I can carry them, or I have stalls for them. I have a a minder service. All of the things related to the horse. And now you basically get a better sense of the stuff that this company does just by doing a very simple selection like this. And I think that for our purposes, this is enough. We don't need any more options. We can either get all the data back, and we'll do an example of that, or we can do a very simple filter like this one here and get something that actually is meaningful. As you can imagine, you could repeat these queries. So first you could say, well, give me all the services that involve horse. And then maybe let's refine the relationship a little bit more. And we're only interested in the services where we can we provide stall facilities for the horse before the transport actually takes place. And so we can sort of narrow it down. But these are the only two things. I hear a microphone. Does somebody have a question? Because I can't see it. A moment for questions, okay? So 2 simple queries, and that's it. That's all we're going to use here. That's all we need. We'll leave it to the experts to do complex queries. They can do that too. They will have fun. They will do I don't know, they'll listen to a 2-hour YouTube. They'll read some books and stuff, and they can do complex queries. Here, it was on 1 slide. It took us 5 minutes. You know, as far as I'm concerned, Sparkle query experts, right? I'm going to stop here for a moment. We're going to now do a practical example of how we do the queries. Hopefully that will clarify things a little bit, but I've done a lot of talking. Are there any questions or comments? And don't worry if you didn't see the previous 2 sessions, it's fine. Just if you have questions or comments, please, this is a good time. Let me go back to the, are there any questions from anyone? I really don't like transcription. There you go. Any questions from anyone? I see that Lasse is on the call. So what is it, Lasse? Is it Vidia Phi, Vidia Oi, or just Vidia? Maybe you can explain that. I can't hear you speaking, but I know you're unmuted. No.
Now you can hear me.
Yes, I can hear now.
Yeah, it's Verify. Yeah, so that OY is actually, it's like, it means company here, limited company here.
Ah, okay.
But Verify, yeah, that's true.
Well, at least I got my question answered. Okay, look, let's go on. Sometimes when you don't get questions, it means either it's clear or everyone is confused, and I suspect it's the latter, but that maybe is an insult to your intelligence, but I would be confused. Let me put it like I would be confused.
Henk, I do have a question, Per.
Okay.
This looks a lot like Transact SQL in SQL Server.
It does, yeah.
So you have the common functions, select, union, inner joins and outer joins, and whatever you want to do. It's the same in here.
It is, except that I don't think there is such a thing as outer joins and unions and things like that, because the relationship of the data is determined by the tuple, not by the list. If you have 3 different tables in SQL, for example, you have a table with first names and family names, and they have another table with family names and perhaps addresses or something like that. You can then use the information in both to find out where does this family live, for example. In Sparkle, that relationship is actually in the tuples itself. And when we combine data sets in Sparkle, we just keep adding them to the list. It's just a very, very long list. So that's actually, you just pick the one example where it's very different. But there is the select, there's the where, you can filter, you can do all sorts of things. But it's a good question, because, and sort of made that connection, but the relationship in relational databases is in the tables, or the between the table. Here it's in the triples, which is a very, very fine-grained thing. So good question. I'm going to think about that a bit longer now.
Thank you.
But not during the session, otherwise it's very quick. Okay. Any other questions? We had the first one. I know the second question because I had the first. Okay, good. Let's go on. Right. Let's query a living lab. Now, for this, I'm going to look at the Internet Logistics, which is the IATA Living Lab. And the only reason I do that is because A, I understand it mostly, and B, I have data for it. Okay. So in this particular example from the world of air transport, and they just made up some fake companies. IATA as an airline, we are not an airline, although some people think that. We're just an association of airlines. BDI as a consignee, BDI is not a consignee, and VDI as a forwarder. Actually, I don't know. Maybe VDI will support forwarders, but I don't think there ever are forwarders, but that's fine. Let's not worry about that. Familiar names with familiar roles. And so in the world of air cargo, bookings are important. I'm pretty sure that's the same in every other part of the cargo supply chain. And so when we have a booking, I see there's an error here because the price appears twice, but never mind. And even transport movement appears twice, which wasn't the plan either. So something went wrong with the copy and paste. But there are a couple of data elements. So obviously we have a price. The booking is, in this case, the forwarder has booked a cargo transport for the forwarder on behalf of the consignee who will receive it from the forwarder. But somehow they all appear in the booking. Makes sense, right? They all have a relationship with the booking. And we need a price, and the transport movement has to do with a movement from point A to point B. We have other things like, what is the preferred itinerary? What is the airplane number? There's at least another 15 or 20 different elements that appear in the booking. But for the example, we're not interested. So very simple. These group of companies are involved in a common booking for a transport. So what does that look like? And now I need to find my browser. So, do you remember the second session? I told you how you could use Jupyter notebooks. You see Jupyter at the top there. Jupyter notebooks are really cool because you don't have to install programming environments or your computer. Anybody can use Jupyter notebooks. I'm using one that's running on my, it's actually running as a server or a service on my laptop. But you can just go to, Google has also got a Jupyter service. The details are in the last session. So it actually shows you how you could go to the Google, they called Colab. I think they developed it for people wanting to learn about artificial intelligence, where everybody uses Python, which is a sort of relatively popular programming language, but you can use it for anything. And the really cool thing is that you don't have to, nobody has to configure your computer, which is really nice. And so here's an example. Let me just take that one out. We don't need that. So you tend to, when you use these Jupyter notebooks, it's really just you're executing a program. Don't worry about Python here. Don't worry about how you write programs. It's not what we're demonstrating. I just need to start up the service so that everything is up and running. So first things first, and this goes back to the last question. Brilliant. I created some files here with some data in it, and the question is, can I find them easily? Let me see if I have something here. I clearly didn't prepare it well enough. Yes, here you are. So here's the first one, just so that you see what we're talking about. First thing you'll see is that it looks very similar to the example I just showed you for the Veloci Italia company. I forget the full name now. In this case, we have a company. Is this the right one? I think it might be. No, it's not the right example. But anyway, what you see here in this case is there's a legal person called, which has a name, IATA, and a website. But that's not actually that's not the one I wanted to show you. There must be another one somewhere. No. Actually, we'll see it in a minute anyway. But anyway, there are so I have a file. Oh, it is the one. I'm not confusing myself. Start again. Another notebook, because this is about the queries within the living lab of IATA. So this makes more sense. So I have to here also just start up the whole thing. Okay, this is where it gets interesting. The first thing is that I have a file that has lots of companies in there. Now that I know what it's called, I can actually show you that one. I'm going to share all of this with you, right? So you can certainly simulate this yourself. Companies, here we are, companies TTL. And what you will see here. Yeah, okay. I just want to show you a document I created, and really it's just, this is using the IATA ontology, so don't try and understand you can't use this with the federated ontology, but we also use an ontology. It's called one record and it has everything in it. So one of the things we have is an element called company information, and in that thing we can put information about the company. For example, what is the ID? In this case is BDINL. I made that up. They may have a server, okay, which is company's BDI-NL. Forget the supported content types, and they have a certain service, okay? So they accept what we call logistics objects, which are like digital twins. And in their case, they have a barge service, they have a truck service, they do milk runs and ECMR. Okay, so I created some companies that don't exist with some services. And this is the data that we have. Now, this is where I come back to the previous question. So for this to work, I first have to upload that data. It's actually running on a server on my computer here. Actually, let's just see if that actually works. It does. So here I get the same data, but in a slightly different format. So it's actually live. This is a live environment, if you want. So I upload that file I just showed you, companies, and this is where my comment was with respect to relational data. I can just add to this same, we call it graph, another document which has booking data, and another one that has pricing data. And actually these are very specific, because this is a specific booking, 038296, and the other one is a specific price quote that we made, which is 077454. So I just add them to the pile. I just make a huge thing. So this was just a prelude. So I loaded some data, which I'll share with you. So the question is, the first one is the very first one that I explained to you. Is half the time when I do this stuff, it doesn't work. So I just want to see that there's data. So here there's a very simple query. Remember that one? Select this thing, this relationship, that, where this relation, that, full stop. Okay. And again, forget the whole Python thing. It's the red thing that we're only going to focus on. The rest is just programming language. I don't care about that. So that's the query. Now we're going to execute it. And guess what? It's picked up all that data, which is about the companies. It's about, so you can see companies here with their services, pharma, live animals. What else is there? Did it pick up the rest as well? In there somewhere. Can't quite find it right now, but I think it must be there. So let's just say it's there. So that was easy, right? So we just looked at all the data we uploaded, and I know this looks messy, and that's because it is messy. It uses the full URLs, right, which is confusing. The only thing I'm interested in here is this price, okay, and whatever data that goes with it. So this is not usable. You would never use this. So let's refine things a little bit. Let's ask myself, which companies are actually in this data file? Which is there? So we start with the same thing, this relationship, that, and then we have this. And then the question is, this is a relationship question. Which of these triples has a company ID, which then of course provides me with the company ID. So if I run this query, I should get a little list of companies. There you go. So it just from that messy thing above, I've done a very simple query, and now I find that in this particular environment, I have BDI-NL, I have IATA, and BDI-OI. Now we know what the companies are. We could do something more with it. I think that when we get around building what you call it, an index for the internet, for the well, internet logistics as well, but for the federated network, we will probably have queries like this. Which are the living labs that are currently part of the overall network? We'll do a very simple query like this, and here's the answer. And then we can look at, for example, which of these companies have bookings, right? That's the next question. So now it's a different one. the relationship I'm looking for is has a booking, okay, with the carrier being whatever the company is. If I run this, let's hope it works. It now tells me that there is in fact a booking that is operated by the carrier IATA. I remember it was a carrier. So you can see where I'm going with this. I have a completely full set of data, and I can do these queries to narrow it down to the information I want. Which are the companies that are there? Which of these companies has a booking? And I think there's a few more queries, but so now I know that there's something there. I could actually look at that booking, or I can query it. Now, in my case, let's query it, right? We've seen that when you look at the data, it's actually confusing. So here I have a simple query, and I say, well, show me this booking. So now this is that booking, and I don't specify who or where it relates to. So that means I get all the data related to this particular booking. And here we go. And this is something you saw before. So this is a booking operated by the carrier in the middle here. You can see that, IATA. There's a price, which actually refers to a price object, right? The price itself is not here, it's somewhere else. It is for a freight forwarder VDA OI on behalf of the consignee BDI NL. So you see, I had this massive data set, and I did a few queries, and now I get the data that I actually want. There's only, I think there's only one question left. What is the price? But it looks like I do another query here. Oh yes, a query about this company VDA.oi. Who are these people? What do they do? So let's just run a query. And now I see that this company has a number of what we call them logistics objects, which are digital twins. For a service they have ECMR, they have salmon, border management, they actually provide a Santa sleigh service, which you know they do. They have road transport, and they sell elk antlers, or they maintain them, or whatever it is they do. So again, the idea with the sort of the whole semantic data network is you navigate it like this. This is why we need to create these horrible looking sparkle queries, is to narrow down the information we want. So we started, just to recap, this horrible data set. We then said, well, let's okay, where are we? What are the companies? Oh, these are the companies. I'm actually looking for a booking from one of these companies. Give me the company that's the carrier for a booking. I have found it, and I'm interested in knowing a bit more about the booking. So I see all the details of the booking, and I also see now, I want to know more about this company VDI, and I could change that, right? I could also say, well, great. If I put IATA here, I obviously get a different answer, because I'll see that we're doing road feeder services, pharma, live animals, freighter services, warehousing services, airway bills. And so we can just query this network. So if you take a bit of distance from what may look confusing, because you may not know Jupyter notebooks, you may not know Python, you may not know Sparkle. Well, you do, because now you're an expert. If you think of this just as this network of data, that's floating around the EU, floating around the world, isn't it neat that you can use very simple queries like this to find out who provides services? What are the terms of these services? Did I book with them, or did anyone else provide similar services? You can ask all of these questions and make sense of all this data that is out there. In this case, it's a very small universe because I've just uploaded the data. But if I go back to the beginning of this little example here, when I do uploading the data here, remember what I showed you here? You know, we're uploading this data. Actually, all this data is already online. And for example, you know, there was this price offer. I didn't actually query that one, but I can just go to it. I know it's a bit hard to read. Can I make this bigger? I probably can, but I don't know how. So here we are. Here's this price, right? Reference price. It is a price object. Okay, that's what this means. Type price. Then what else do we have? We have a charge code, CC. We have a grand total price. There's all sorts of stuff in there, but grand total is 320, and it was valid. It is valid up to this date, which is in the past. So if you wanted to book this service, you've missed it. You'll have to get a new quote. So coming back to the example here. So in this internet logistics, this data is actually already live and online. And so these queries could be run directly from these endpoints, which what these are. And that is what we're trying to do here, is that each of these labs and any company afterwards just put the data on a query endpoint, and we can start accessing it without loading it. The reason I have to load it here is that although the data is online, it's not actually technically an endpoint, a Sparkle endpoint. So I needed to upload it. But at some point, we'll actually put this online in a Sparkle endpoint, and then you, from your desk, could run exactly the same queries on my data, on our data, and get exactly the same answers without you having to transfer any data. So that's kind of cool. So this is what querying data in a living lab looks like. Now, of course, the peculiarity of the let me go back to the slides. I'll find them. Yeah. Like this. No. Now, the peculiarity of the internet logistics is that the whole point of this is very similar to the federated network, which is that there will be hundreds, at least 100 airlines and thousands, 10,000s of forwarders that use air transport that will all be present in this environment. And so this really looks very similar to the federated environment. So the example here is quite appropriate. But as we'll see later, in your lab, you have your own environment with your own stakeholders. And so you could also do very similar queries. They would it would very similar to what I've just showed you. The trick, of course, is getting the data in the right format. But we talked about that in the very first lecture on this seminar. Good. So this was one example. Now let's query the whole federated network. And for the purpose of today, I've limited the network. This is wrong. Let's correct that. No, just call it platforms. Okay, back to this. So here we have a very simple federated platform network. There's IATA, Conagnotto, there is Simple, there is VDA, there's BDI, and of course anything else we want to add. So let's say that we've actually created this. And let's say that VDA has some data that I'm interested in, and here we can see using the actual federated ontology, there's a business transaction which has an involved party called VDA, and it uses transport modality road. Okay, so you kind of follow the story here, and I think this one only involves VDA, but obviously we could do the same thing with anything else. So I've created some example files where these companies exist, where this particular business transaction exists as well. But of course, at some point, hopefully, all of us will be present with our own semantic endpoints so that we can do queries like this without me having to create fake data files. So that's one approach. I'll come to the other approach a bit later because there's lots of issues with this. But anyway, so I'm simulating a federated environment of platforms. So what's next? Well, next is that I now need to take you to the other notebook I prepared earlier. So I already started up the environment, so that's fine. But so here, again, I need to load the data because this data is not currently available on semantic endpoints of these companies. And so I added in, in fact, I see that one is missing. Which one is missing? one company out by the looks of it. But anyway, so I included the data for IATA, I included the data for Vidia, for Condagnoto, for Simple, and I included the transaction. Okay, so I put all the data in there. Normally, I would go to the endpoint. So normally, this would look something like, let me just copy this. It should look something like more like this. Let me just type it in. HTTPS www.iata or FEDeRATED whatever company. I'm making this up. So normally we would just give the URLs of these companies and then we get all the data automatically. But at the moment, that's not what's happening. So I upload the data and then I can do the queries. So first query, like the last one, let's just see, no, not like the last one. I'm going to copy the general query I did earlier, which was this one here. Let's see if there's any data. And I just create a new. So here, just find out what data we've actually loaded. It works. Okay, this is all the stuff that's come in, right? It's not as much as the previous example, but you can see the names here. There's Vidia, there's D4U, there's Simple, there's IATA, and then there's some other stuff in there. For example, it includes websites of the various companies. So here's adiv.es. So this is a very general query just to check that I actually get the data. And now I'm going to do a transaction, sort of a query to see, okay, what is that business transaction? And let's say, how did I get that? Well, maybe I contacted Vidia and electronically or in other ways, hey, I know there's this business transaction, but what about it? So I have the URL, okay? I could have done a query and say, give me all the business transactions, just like I did for the last example where I found all the bookings. There was only one. Here, I could find some ways of saying, okay, give me any business transaction related to Vidia, etc. But I have it here, and I'm just going to run the query, and you'll see what it's doing. No. So here. So here we see that. So there is a business service with a business transaction. This is all from our ontology, from the FEDeRATED ontology. And what we see here, there's an involved actor and there's a has service. Now, and then you see this weird code. This is where I think things are a little bit unfortunate. When you write these when you publish your data, there's a lot of data that is linked to other data through the triples. And some of this, sometimes you're very clear about it. In this case, I know that there's an involved actor and that there is an involved actor which happens to be Vidia. But it's actually two triples that are linked. And unless you specify, you give that link a name, it will make it up for you. And so this is not very useful data to look at. I actually am curious if I could just click on that. Give me the data I want, so that's not going to work. So the thing we're looking for really is, okay, who is that? Who is that actor? To be honest, I was working on this last night and I didn't get any further than this. But if I take you back to the actual file, open up the booking, business service DTL. Is that the one? Sorry, that's the whole ontology. So here's the data we're actually querying. And what you can see here, that is this business service involved actor, which is part of the transaction. That one we found. But then because the business service actor name is at the next level, we don't have direct access. If this was at the same level, we would see it immediately, but it's not. This is actually a question I have for Cornelis. I doubt if he's on the call. I haven't actually checked, but to see if this is an easier way, because now think about it, right? I have this data here, and the transaction has a service. The service that it has is a logistics service, and the logistics service that it has is a transport service, and the transport service that I have uses the transport modality road. So, okay, from a semantic standpoint, that makes sense. That road is a transport modality, part of a transport service, which is part of a logistics service, which is part of the service that is included in the business transaction. It makes perfect sense. But to query it is kind of a little bit lengthy here. So I need to check with Cornelis if there are some shortcuts. I know there are. We could write a more complex query that would give us that answer immediately. But going back to the thing here, what we see here is that a very simple query that looks into the transaction only gives the top level elements: involved actor and has service. And so if I would add more levels to this query, it would actually find the real answers I'm looking for. But that A takes me too far in what we're trying to do here, and B, I ran out of time. So even just to prove you how amazing it is, I didn't do that. So going back to this was about a query in the federated platforms, network of platforms. What Roland and all of us want is to be able to do this, to have at least, here I've got 5, have at least 5 or 6 labs that are actually able to do these sort of queries. So that when we go back to the EU, we go back to INEA, CNEA they call them, and I ask that question and say, well, you know, you guys have spent 5 years working on the federated network of platforms, show us what it does. What we really want to do is in fairness, out of revenge maybe, show them this, show them queries like this and say, well, we have a network of platforms. There's a whole bunch of business transactions related to media, in particular to their cross-border Santa services or whatever. And this is how we access that data online and all that stuff without us uploading data before. So that is what we're trying to do. Here. So we're supposed to be here. This is what we're trying to create. Now, if worst comes to worst, and don't tell anybody I'm telling you this, we could fake it, right? We could say, well, we didn't manage to get an endpoint up and running, but we have extracted some data from our lab. We have put it in the right forward. We've put it on this this Jupyter notebook, and look, the queries we can do are absolutely amazing. It's the first degree of faking it. And although I don't think we'll get away with it, because I obviously CNEA is not stupid. In fact, I've noticed that anybody that has money and that gives it away to you is not stupid. They always ask the wrong questions. So they're going to check that this isn't fake. That's the first thing. Secondly, what you could also do is say, well, you know, I don't know, we're IATA, we have all the data, we just haven't managed to make a nice Sparkle endpoint working. We could ask our friends from, I don't know, Conagnoto, if they can host our data, which they can. So then we're sort of halfway faking it, because now it's a real Sparkle endpoint with real data. We just don't tell them how it got onto the Sparkle endpoint. These were the scenarios we discussed in the first or second seminar. But ultimately, we should really all have these endpoints working with some real data. And I can tell you that we're not there yet at IATA. So what's next? And let's sort of dive into that. And then we still have maybe 10 minutes left for discussion. What's next? I think that firstly, what have we achieved? Let's celebrate first. Is that we did this 3-part trilogy, not a 4-part trilogy. And the first question was, how can we use the model in your lab? Okay, so all that, we worked through it. Hopefully you were there. If you weren't there, by all means, have a look at it. There's a video and there's the slides. And ask yourself, how can we use the model in our lab? And you'll find it's easy, and at the same time, once you start doing it, you'll get lost. But that's fine. Anytime you do something new, you're lost. It's good. It's a good way of learning. Second seminar was about how to implement semantic adapter. Okay, and then the third one was how to query your own data and that of other labs. We've done that here, so we can tick those boxes. But there's a lot of stuff I think that are still missing. And the first one is what exactly will the labs be interacting with or on? That was actually the homework from the first session. And maybe you have an answer to that. And I know that I've heard some labs that are actually in discussion with other labs to try and understand what they can do, which is great because this question absolutely needs to be answered for sure. Even if you can't do it, you still need to answer it. The second one is, how should we use this network of platforms? I think a lot less obvious, and we're going to try and answer it on the next slide. And the third one is how does this federated semantic model compare to your own living lab model, which may or may not be semantic. Chances are it isn't. So I'll give you the answers for IATA. And they're not necessarily where I want to be, but the first question, it's a TBD at the moment. I know that there are some labs that we could work with, in particular those that have already got compatible technology. I know that VDI has done some stuff that's very similar to what we do. I know that Rudy's lab is working on stuff that we do. So there are some options there to find some living labs to actually interact with. The second one is, how do we use that? Now, this is, for me, is a big question. When I look at our lab, which is the Internet of Logistics, for us, it's very clear who interacts, right? In our world, we have airlines, forwarders, customs shippers, consignees. There's all sorts of people in there, ground handlers. There's all sorts of other parties. There's road feeder services, dangerous goods, whatever. These are companies that work together every moment of every day. And so we know exactly what they need from each other. We know exactly the data that they need to exchange to be able to do something. And so that's fine, which is why we can create an ontology that works within this Internet of Logistics. But what would these companies need from your labs? This is not as easy to answer. For example, if I think of the work that Simpler does, which among others has this railway network, they can give us information about exceptions in the network and the network and issues. But how does that relate to air transport? I can't answer that question very easily. Obviously, yes, freight can come from an airplane and go to a train. It's a very simple connection. I don't know how meaningful it is, but yes, there is a connection. So the question is, how important and meaningful is it? So I am not sure how easily we can answer this question, but I know that you're asking yourself that question when you're trying to answer the first one, which how can you interact with others? The next one is a little bit more. This is also where a lot of you or your colleagues will have some questions. Is how does the model compare to your own living lab model? And so here's an interesting case, because the IATA, the Internet of Logistics, has a complete ontology. It's tested, it's well designed, it's used, it's there. We have an ontology where all the concepts that we have, we know they're valid. Many of these concepts also exist in the federated semantic model, but because the semantic model of federated is by definition multimodal, not everything is done in exactly the same way. And so when we stick with the example of a booking or what was it, business transaction or something, this structure is very different. And so although we have the data that the federated model might need, it is not in the same form. And so what we can't do is just put our data out there and expect the federated companies to access this data and make sense of it, because they will be using their own model. And so there still needs to be a process which is called alignment, that, for example, if you do a query like, does this forwarder have a booking with an airline? If you do that from a federated perspective, we somehow need to translate that from the federated language into a language that the IATA folks understand. So there's still some work to be done there. So technically, yes, we could launch an endpoint, but it's not enough. So there's still a bit of work there. But I know from my discussions with Cornelis and his colleagues, They think of this as trivial, so that's good because I don't understand how it works. But I think they think of it as reasonably trivial, so that's fine. That one we can come to a resolution with. The next one, and I don't know if there's any architects on the call here, but our IOL data, Internet Logistics data, is, as I said, already in RDF available online, and we can launch a Sparkle endpoint. But I also know that the way that the airlines and their partners manage security and data access is the way that either we have recommended or the way that they like to do it. But one thing is for sure, it won't automatically match any Sparkle protocols. Protocols. Do some spell checking here. And so we're going to have an issue with that. We're going to have an issue with the fact that we might get a beautiful Sparkle endpoint running, semantic endpoints, and then we go to, I'm making this one up, we'll go to Lufthansa and say, all right, for this particular flight and this elbow number, give me the security status. You know, has the thing been security cleared or not? And they're going to say, well, I don't know who you are. We're not going to give you access to the data. And so we're going to have a clash. And so I think that's the sort of thing that all of our labs will encounter. And so within the architecture group, we need to think about this very carefully. And it's a very special challenge because Sparkle is a protocol that defines this stuff, and we can't change Sparkle. So again, we have to do some interfacing. Coming back to the question, how should we use the federated network of platforms? And so I take an example here of 3 different labs. There's one that does last mile in Sweden. There's one that manages a train service in Spain, and the other one provides airline bookings. Question: what's the link between these 2? Answer: there is none. These 3 things are not linked. What happens in practice is that starting from the bottom, the lab that does airline bookings, they have lots of partners, forwarders, airlines, etc. It turns out that one of the forwarders that is linking with that lab does have a relationship with the train service in Spain, and it could be via different parties. And the train service in Spain may well have a link to the last mile in Sweden because there may be some road transport or air transport involved. And so, yes, all of our labs are linked via our customers and partners, but I think as a current test federated network of living labs, that relationship may not be so obvious. So I think I think that we need to do some deep soul searching in, and this is the sort of thing we can do at Malaga. It's the sort of thing that I think Roland will be very interested in. Exactly how do these labs relate? And does that mean that we either need to find those parties that create those links and set up a fairly, if not very complex network just for the purpose of proving something? Or do we accept that there is no obvious relation between some of these labs and we're going to have to fake it or come up with a relationship that it's useful but not meaningful? For example, or the other way around, finding out, I know, I can ask the Spanish lab if there's any disruption in the rail services. It would prove that the network works. It wouldn't serve any purpose. So I think this is a question that we all are reflecting on and need to reflect on. So I think that this sort of finishes this trilogy, but I think we need more. Certainly through the semantic modeling group, we can continue these discussions. I'd like to spend some time with Cornelis to see if we can come up with some clever strategies for some of the questions I've raised. And absolutely, in Malaga and before Malaga and after Malaga, we need to get a much better understanding of what we're trying to achieve with the federated network of platforms, even just from a semantic interoperability, but really what is it for, okay? And with that, I'm going to stop talking. We have a few minutes left. Let me just go back to I think it's this one here. Any thought from anyone? Rudy, go for it.
Yes, Mats is here from Stockholm.
Okay.
Can you hear me?
I can hear you, yes.
That's great. I was just, this was the first time I was attending this
Good.
information. But anyway, I have personally quite a lot of experience from SQL queries for the past, from the 80s and 90s. It's almost the same. But the two first lessons, if I may call them that, are they recorded somewhere at the website so I can listen to them?
Yes, they are. And I think they're on the, if you go to the FEDeRATED, let's do this together actually, because it's actually a useful question. Let's just go to the FEDeRATED, because I always have to Google a bit myself to find out. I believe that, where would they be? Any suggestions from anyone? It could be home, maybe. No, not home, obviously. Yes, you are. If you go to the FEDeRATED news, there's tweets here on the right, and there are discovered. There they are. There's at least the second one is here, and is the first one here as well? Yeah, that's the one. The tweets on the right. That's where you can find both the YouTube and I think the PowerPoint's there as well somewhere.
Okay, great. We're trying to create some kind of semantic web model in Sweden between our living lab and the rail operators.
Fantastic.
And the harbors in the north, Umeå, as you know. See if we can try it out somehow. Nice.
Okay. Rudy, you had your hand up as well.
But I also took it down. Huh?
I know, but I still want to hear your question.
Yes. It is a lot of thinking for Malaga, of course, whereby I'm looking at the story from the IATA side. So assuming that Living Lab 17 is a forwarder. So as a forwarder, I want to access the data of the airline through a semantic endpoint. In the beginning, it will already be a big achievement if we can just use the IATA ontology. There is no reason in the beginning to do different in the first step.
Okay, that's a good idea.
Yeah, the other way around is a little bit more complex. Is how to present my own data, which I do have as a forwarder, as an endpoint that can be consumed by others. And for me, these two objectives, this is already a big achievement at a certain moment. But I see it happening. I see it happening. Then also when I access the data from the airline, I just see that I just think that at the moment we want to consume the data as a reader, as a consumer. We just receive a small data set with the triples, and we consume it locally as a consumer. Yes. I see that to be the security way around, in the beginning. Yeah.
I agree, Rudy, and I think it's very important to take this pragmatic approach. And I think it's what we discussed in the second session for those that haven't seen it, is that we need to be smart about how we approach this. We need to find shortcuts. This is a great shortcut. And I agree with you that if we can get just semantic interaction, even with the same ontology, is already a huge improvement. Yeah. And then I think we can work with the experts from TNO to take it to the next level. I know they can help us do that.
Yeah, I agree. That's a problem for people like TNO to solve this. If we already can convince an airline to provide us the data in the format of triples, that's already a big step. And once we receive them, they agree with the security. So I guess that the security is then the bilateral relationship between the airline and the customer in the beginning. Yeah.
My guess, Rudy, is that from a IATA perspective, although we have all these we have our own pilots everywhere, and they are implementing this. Probably for the purpose of our testing, we would take their data, but not host it directly. We're not going to get access to their operational environment. I wouldn't recommend that. But we can get the data, and it can be relatively live. Okay, so we can do that. Incidentally, I was thinking of another use case that is truly federated for every single lab, and which is the EFTI.
Yeah.
You've said it a million times, but it's the one thing that virtually touches every single lab.
Yeah.
If we could use that as a common use case, then A, we would get brownie points from Europe for doing it, and the subgroup 1 would probably take us out for caviar and lobster or anything else you like. You may not like that. So that is another one I think we could possibly think about.
I agree that, and maybe we should consider to use what I've seen with the US Customs to organize something like a fest or something like that, and maybe in the beginning of next year, and do that exactly. Every living lab can provide some EFTI data. Yeah, that would be nice. Yeah.
And that's also a very easy use case to test, because we have the data, obviously, and we can put it in the right EFTI format, and then see how we can access that. And so that is another thing that it might be the easiest, and if at least we can do that, we've done something. You talked about the fest. We just finished the hackathon last weekend, not last week, week before, and stuff like this. These companies are doing it. I've seen them implement these ontologies. I've seen them do it, so it's absolutely doable. But we just have to get our head around it. Any other questions from anyone?
Over my hand and switch off.
Okay. Anyone else? Any questions or points? Well, in that case, on behalf of the management, I'd like to thank you very much for participating. No matter when you join, no matter how much you took away from this, you're already in the top 1% or less of the world of engineers and computer people in the knowledge that you have gained in these 3 sessions. Obviously, it doesn't make you a Nobel Prize winning semantic expert, but you're in a very select environment. And so I think you'll certainly be able to confuse your IT colleagues with the knowledge you have, confusing in a good way, and certainly impress them. But this is not the end of it. We'll continue this. If you have thoughts, questions, you can always reach out to me. And in the meantime, I will think about a follow-up. As I said, I'll discuss with Cornelis. I'll discuss with Roland to see what is the best way to move on from here. Because this is really just the kickoff. This is the starting point of this discussion. And then we will take it from there. So thank you very much. And you all got a diploma, by the way, in the PowerPoint presentation here. You have to put in your name, and then you're good. All right.
Thank you very much. Thanks, Henk, for this interesting workshop. Thanks very much.
Okay. You're very welcome. Thank you, guys. Have a nice day. Have a good week.
Have a nice day. Ciao.
Thank you.